So yeah, onwards with Fest 3, delighted to welcome Owen Cox from Planar Heaters. And there's a reason why I was particularly keen to get Owen to come and speak. Some of you will have read the report on the incident on the diversion. The MAIB have issued, not the full report yet, but a safety briefing. And that's all to do with installation of diesel heaters on boats. That's very much Owen's background. Owen, I know you're also a sailor as well. I'll leave you to do a little bit of an intro. So without further ado, over to you, and thank you very much for coming to talk today.
Thank you. Well, good morning, everyone. I'll just no, I won't. Sorry. There we go. Right. Yeah, I'm Owen Cox. I started planarheaters.co.uk about 5 years ago, which basically started because I wanted a heater for myself. I've done a lot in the background, as you'll see here. 20 years or so as a marine engineer, specializing in electronics, refrigeration and air conditioning. A lot of that has been on yachts. In fact, most of it has been on yachts. Had a company out in Mallorca doing super yacht air conditioning and refrigeration, which obviously involves a lot of heating and air ducting and the like as well. So then I wanted a heater for myself. So I found at the time what was a very new product from Russia, the Autoterm. And so I installed one of those, realized that nobody was importing them and installing them and supporting them in the UK, but they seemed like really good quality. So that's what got me into heaters. I decided to bring them in, and since then it's gone from strength to strength. So I do an awful lot of yacht work at the moment, and also I'm now technical director. The company's grown enough that I don't have to get myself so involved in the sales side of it. I just get involved in technical support and installs now. So there isn't anybody who knows more about it on the Autoterm heaters at the moment. So the first thing is, how do they work? I'll start off with a really basic run over. This is a standard heater, and basically you've got a fuel pump, you've got a heat exchanger, which is a big aluminium section here, that has a burner inside it, and basically we take combustion air in here. There's a fan in this section which draws air in from outside for the combustion. There's a glow plug which heats up to get it warm enough, and then the pump pumps fuel onto the doors inside, which will be hot, and if it gets hot enough it will burst into flames. Then the fan blows the flames inside this burner chamber, which will then heat up the heat exchanger around the outside. We have a temperature sensor at this end here, and that measures, some heaters have two sensors, one in the exhaust here like this one has, and one on the end of the heat exchanger. That has, on the simpler ones, it has a dual function where it tells if the burner is working and that the flame is lit, and also it operates as an overheat sensor as well. So in the case of the ducting being blocked or restricted, temperature goes up too much because there's not enough airflow through, and that temperature sensor will click it off. The same, it works slightly differently with the ones with the sensor in the exhaust, but obviously that just works to tell you if there's flame failure and that it's established a flame in the first place. Then there's an ECU which controls all of this, and now most of the time the fan here is a brushless motor, so they tend to be lower power, last much longer. Typically 20,000 hours running now would be expected out of a fan motor. And there's a lot of design work going on with the fuel pumps. So most of the big brands now are doing a silent or near silent pump, because that was always people's biggest complaint, especially on boats. It's very difficult to mount the pump in a quiet place. So here's a cutaway of an actual heater. That's one of our 2D heaters. You can see all the parts. There's a fan here, which is the one that draws air in from the return air side across over the heater, and then out of the other end over the heat exchanger here. You can just see the red part is the painted inside of the burner. There's your glow plug, and that one there is the combustion air fan for flame, and obviously the ECU on top. So we'll go on to a bit about the installation side of it now. The electrical side of it, basically every heater should come with its own loom, and hopefully they will come with fuses. Certainly ours do. They come pre-fused, pre-made to length, usually a 5 meter length. So you should have plenty of length to get that straight to the batteries. On the safety side of it, the biggest problem we have seen with them on boats only, because it only tends to be boats that this happens on, is that people connect them via the isolator switch. So they forget to turn the heater off and just turn the isolator off. And that will mean that the heater shuts down without doing its controlled cool down. And so it will melt the fan or damage the heater in some way or another by being overheated, because it needs to run with the fan for a long time before you turn it off, just to cool down the body of the heater itself. Otherwise it can melt its own internals. So on that front, I do recommend that you connect straight to the batteries and not via a isolator. Or if it is via an isolator, make sure it's one that the owner is well and truly aware that he has to do a full shutdown before turning the isolator off. So now we're coming to part of the discussion about the diversion report. This is actually the installation onboard diversion. Just to talk about exhaust fittings really and why it happened. We'll come on to it a little bit later, but basically this is this is how most of the exhaust pipes are that are supplied these days. This one is a Chinese version, so you'll see these pipes, which I think have absolutely no place on a boat at all. They're really thin. They don't handle bending very well. They get very, very hot, especially if they're connected to a Chinese heater, which we'll see again in a little while. And these type of silencers are spot welded rather than fully welded. So they just definitely have no place on a boat. Under a vehicle, road vehicle, it's not a problem. A bit of leakage, it will just blow away in the wind. But on a boat, that's leaking straight into the cabin effectively. And if it's installed like this one, the return air into the heater is round there, and it will draw it and blow it straight into the cabin. So that's what happened with that particular one. They had a Webasto one, which Webasto and Ospacher use exactly the same type of silencer with spot welds on there. We actually have a fully welded silencer, so ours are actually okay for it. The only weak point there is the hole where the bolt holds it. That is not welded inside there, so what I tend to do is use a bit of exhaust gum and put a bolt in there, and that will seal it. But to be honest, I tend to nowadays just use a standard marine exhaust, which I'll show you soon, because they don't have any joints in at all. They come pre-made up in the factory with all the joints done, so there are no leakage points done on board. There it is there. That's one of our pre-made exhausts. So this is the bit that's inside there. Usually when they arrive, they're actually inside 60mm ducting. which works amazingly well as insulation for exhausts. These can get typically, you're looking at around 150 to 200 degrees on the exhaust, getting cooler as it goes along. And obviously, if you're installing it in a locker, it's very likely on a yacht that anything will move inside the locker and can touch against the exhaust, and you don't want that catching fire. So insulating the exhaust is very important. Like I say, ducting, if you take one of those exhausts like that and you put 60mm ducting around it, even without any insulation inside, which we usually do, some glass fiber webbing type insulation inside of there. But even if you don't use that, you can actually hold that exhaust while it's running in your hand through the ducting, and it won't be too hot to hold by hand. Whereas if you were to try and grab hold of that exhaust without any insulation on, it is very hot. You wouldn't be able to hold it. An important point on there is when you're installing it, the only joints then will be at the heater end and at the skin fitting end. And I would recommend sealing that with exhaust paste. What I tend to do is put the paste onto the fitting that you're going to put the pipe onto, because we've seen a lot of them where people put it inside the pipe and then push it on, and it sets blocking the hole, so it restricts the flow. Now these heaters are very, very critical on the airflow through the heater and through the burner. If you reduce the airflow, you effectively increase the fuel mixture, so they soot up really quickly. And we do see some problems where heaters are sooted up in 10, 11, 12 hours just through the fact that the exhaust is restricted by exhaust paste when fitting it. So here's some locations of where they can be fitted. It's recommended that where I would normally say on a yacht they have to be is somewhere in the aft end of the boat, and I would always put the exhaust as close to the center line as possible and as high up as possible in the transom. Now that's not always possible or practical, so we have moved them around as necessary, but also in some cases where the combustion air intake isn't possible to get into a ventilated area, because you want to draw air from a locker or something if possible, preferably one with a vent to fresh air. You can also fit that to a skin fitting. So what they're showing here is if you've got the exhaust on the transom, you should have the combustion air intake on the transom. If you've got it on the rear quarter, you should have them both on the rear quarter, not too close to each other so they don't draw back in. As long as they're 100 mil apart, you should have enough free air to get them to run properly. What you don't want is this situation where you've got one on one side and one on another, because if you can imagine, if the wind's blowing from the starboard side on this boat, it'll be blowing air through the heater and that will make it run leaner. But if it's blowing from the transom over the stern towards the bow, it'll push the exhaust and put back pressure on it, and that can also blow the flame out in extreme circumstances if there's a lot of wind. We don't usually find an issue with it if the combustion air is installed in a locker. We haven't come across any cases where it's blown out. If it did blow out, the sensor on the casing will know that the flame has gone out, or the one in the exhaust, and it will shut down the heater in a controlled fashion anyway. So it's only more a point of using the heater than actually any issues with safety on that front. I've got this in the way here so I can't actually see. There we are. Right, so then on the exhaust side of it, so they're using one of those generic complete exhaust systems in this case. They come in a length of 2.25 meters, and that is the maximum that is recommended length for running those, because the drag of the silencer will slow down the flow. So most heaters generally, if you've got no silencer, you can go 3 meters with the exhaust. And we usually say 2 meters if it's got a standard exhaust silencer in the middle. Those marine exhaust systems actually have longer silencer and they have less drag in there, so they can go to 2.25. So you want to mount the heater within a maximum of 2.25 meters of wherever the exhaust is going to go. Now on this particular one, you'll see number 3 there is they've got a condensate drain. We actually don't end up fitting many of these because we haven't found it to be a problem. If the exhaust is hot enough and well insulated, there won't be any condensate in the exhaust. It will just condense out of the skin fitting overboard. What is critical is, as you see, they've got it with a swan neck to stop seawater coming in, which obviously is one of the reasons I tend to say fit it towards the middle in the center of the transom, because it's the one place on the boat that is least likely, although on most yachts it's always possible to get water in, but that's the least possible. So it's not good to fit them forwards generally, with the midships, for example, where when the boat's heeling, water can come straight up the exhaust. So that's, but yeah, they put a condensate in, but we don't tend to. There's a typical skin fitting with the pipe through the center and then an insulated section so that it doesn't get too hot going through the GRP. I have seen a few where people have used normal skin fittings straight through there and tried to put it on there to save a bit of money, and it does get very, very hot on the GRP. I've seen some of them get very scorched around there. Right. So there we go. Just a bit of a summary there. So again, the joint should be sealed to keep it as tight, gas tight as possible. I use proper exhaust clamps instead of Jubilee clips, as comes in some of the kits. Jubilee clips just don't tighten up enough, and it's not good to use those. They will go. What we tend to do is put a short slit in the pipe as well, so that it allows it to tighten up with the clip. In this particular one, this was a comment on the diversion one, which we can look in a bit closer in a minute, but I couldn't see in their pictures exactly where the combustion air intake goes, but it looks like it could be a non-standard type pipe. It looked like rubber hose to me, and also could be running somewhere long, although it's out of the photo so you can't see it. So it may have contributed by making the heater run richer and possibly not combust properly. So it's creating more CO. Again, exhaust skin fitting high as possible, swan neck, and as I say there, yeah, everything I've said. So we'll move on to fuel systems. The regulations on them for private yachts on the sea, there actually aren't any rules as such. However, if you're building to RCD, you do need to have, as with the engine systems, ISO 7840 parts involved. Inland waterways also state that in their requirements, so canal boats would need all of this. And something they say about is that you need a shut-off isolation valve and an ISO 7840 fuel filter as well. So we actually have these kits. All the manufacturers do a kit like this, where there's fuel pipe and clips and ISO 7840 hose, stainless clamps, and the hose nipples. And then we also supply this filter, which has a shut-off valve on it as well. And you can either tee that into the fuel line existing, or you can go with a dip tube that comes in the kit straight into a tank, or off a specific takeoff that was built into the tank. So another question I get asked about a lot is CE marking. I've tried to find out all of the details on this, and these are the only references I can find on CE marking for heaters on boats. The plastic fuel tanks should be CE marked from what I read, and coded vessels need all equipment on board to be CE marked. Now there's quite a lot of clone heaters around which are not CE marked, or they say they are, but it needs checking up on an individual basis, because some of them are, some of them aren't. All I can say is that the main 3 brands at the moment are all properly CE marked, and most of them go way beyond it with E2 R122 or R10 type approval for vehicle installs, one of which is an electronics harmonics standard, but the other one is actually for diesel heaters fitted in vehicles. Now I know that's not applicable to boats, but it is a useful guide to know that it is safe. So Autotherm, Webasto and Eberspacher all comply to those, and there's quite a few out there that don't. So on the fuel system, you have, as I said, a couple of ways of installing them. There's the dip tube into the tank. This could be welded into the tank as part of the manufacture of the tank, or we supply the dip tube that will go in there that you can fit yourself. Then a joint piece, again, that'll be the 7840, then the fuel line, copper pipe, a meter maximum. These pumps push better than they pull, so it's always good to get them within a meter. Now it says here a maximum of 4 meters, but we can actually go much longer than that. I've done some 10-meter runs. As long as the pipe is after the pump, it's not a problem. Again, you can do exactly the same thing. We sometimes go off the main fuel filter of the engine itself. If it's a CAV type filter, just get a fitting that will screw in there, and then put a valve straight onto that, and then go from there. But if we can, we'll go direct from the tank. But sometimes, boats being boats where they're built in, it's not always possible to get to the tank to get a connection onto it, especially when we're retrofitting a lot. The angle of the pump can be quite critical. It's usually around 15 to 20 degrees. It just promotes getting air out of the pump, and particularly with the more modern pumps now, with the where they're more silent running, they do need to get every last little bit of air out. So at least 15 degrees on all of those pumps. The older Thomas Magnet ones, which most manufacturers use, would actually want 0 to 5 degrees, but I've always put about 15 degrees on all of them, and I find that works the best, gets the air out quickly when priming them up. So here we go. There's a better picture now of the installation. Just describe through it. This is on diversion. So it's mounted up behind this sort of dashboard area, as you can see. It draws the air straight from this area, and when they opened all of this up, they discovered the road vehicle type silencer in there, and it was very unfortunate that it had been running for a long time, and without them on board, they came on board and it all settled into the boat. So there we go, that's it, opened. Something to watch with this exhaust pipe, particularly on the top here, if you bend this very tightly, it can split the pipe open. So something to do is where you see these swan necks, just give them a waggle, because you can sometimes find that they are very, very loose at the top, and the way these exhausts are wound, if they pop apart, they get very, very loose. It's very obvious when they are broken inside. And if they're broken, they will leak. They can leak quite badly. So do look out for that. Again, that looks to me to be rubber air hose, which isn't, sorry, rubber water hose, like radiator hose, which doesn't look to be the right stuff either. So obviously I don't know where that goes, and if it only goes a short distance, it may be okay, but it seems a strange pipe to use for that. So there's a there's a demonstration of how hot the exhaust can get. This one is obviously glowing cherry red. So if the heater is not burning properly, again, so this comes down to possibly the way the exhaust is, or in this case, I suspect it's the fault with the heater itself, or the burner, or the fuel pump settings that can be adjusted in these ones. But I think this is sooted up, so the flame is actually tending to be pushed all the way down the exhaust rather than into the heat exchanger, and it's very, very hot. You can see it's even scorched the plastic casing. Now, normally the overheat sensor should have cut that off, but it has been known that they don't in some cases. This is a picture I just picked up off the internet of somebody demonstrating how they'd installed their heater on a Bavaria. I thought it made quite a good thing to show how people can make mistakes in a way. He's got his exhaust there very low to the waterline. Now I would have fitted that a lot higher up, because I think it wouldn't take much heel to get water to cover that over. And also his swan neck doesn't go very high up. I would have liked to see right up. It's hard to see exactly where the transom is from that angle with that photograph, but I would really like to see it up at this height. Really, would have been a lot better, and have the swan neck right up to the top of the deck level. That would make it a lot safer. I think it wouldn't take much water to come over his swimming platform to fill that whole thing right up with seawater. So that is a bit of an issue. I'm afraid I've rattled through this quite quickly, so I'm hoping you've got some questions. But has anybody got any questions on it? I seem to have really rattled through that quickly.
Downstairs at the moment, but we've had a question.
Sorry, I heard a little bit of that, but it disappeared then.
Is that any better?
Ah, yes, that's it. Yeah.
There we go. So morning, Owen. Some of your competitors' products can be very fussy with supply voltage, often locking out.
Yep.
Do Planar products have any design features to improve this?
Well, ours, they don't actually cut out until they get to 10.5 volts anyway. So by then the batteries will be very, very flat. We do have a new controller, which is just going to be released probably early next year. We've had a couple of them in as a trial, but that gives you the option to set your own level. You can set that between, I think it's about 10 volts, maybe even 9.5, right up to 11.5, 12 volts, wherever you want to set it, really. So yeah, that we don't find it as much of a problem. I know that some of them were very critical on it, but a lot of that does come down to how they're wired up. We do find that, again, part of connecting it straight to the batteries rather than going through a switch avoids a lot of voltage drop in a lot of cases. And that's caused a lot of problems where we've gone through switch panels and they cut out very early, way below the voltage they should do, or way above the voltage they should do. Sorry, because of voltage drop in the cabling and the switch itself.
Okay, Graham, does that satisfy your answer, your question?
Yes, that helps to a certain extent. I think Owen's probably right in terms of some of the wiring issues can obviously play an important part. My focus area is narrowboats, and narrowboat owners tend to be quite happy to lash things together and then complain the kit is the problem. So yeah, I think that's a valid answer. The new controller sounds interesting to be able to set levels, because sometimes these lockouts can appear to be a technical resolution rather than an owner operator resolution. So anything to help the owners, I think, is useful. Thank you.
Mikhail has a question. Are you able to unmute your microphone, Mikhail? I think I've asked you to unmute to see whether you want to chat directly to Owen.
Yes, good morning all, and good morning, Owen.
Good morning.
What I've seen is that especially in warmer climates where these heaters hasn't been used for a while, they always get clogged up and create issues.
Yep.
What's a good way to maintain them in warmer climates?
Well, we always recommend to people, no matter where you are, whatever you're doing, once a month, give the heater a good blast at full power. So turn it as high as you can go. In the case of doing it in warm climates on a boat, ours you can set to a power mode rather than a temperature mode, because they won't actually start if it's over 30 degrees on the temperature mode. But if you put it to power mode, they will start and they will run. So we just set them to the maximum, run it flat out for an hour, and that will keep the burner clean. It moves all the parts. The biggest issue we see when heaters have sat like that, especially in warm climates, is diesel bug growing in the line between wherever it's picking the fuel up and the heater itself. So the minute you start it, that bug gets sucked straight into the pump and clogs it up, or it clogs up the little nozzle where it goes into the burner. And so in one of those, it ends up blocked up, and it either means that you have to clean out the pump or replace it if it's really bad. And the same thing with the burner, that they can just get clogged up and you can't really get in there to fix them. So definitely run them once a month, and that should resolve it.
Okay. And the other question, because I was quite shocked about this exhaust picture you showed me, how hot this exhaust can be.
Yeah.
It can be really, really dangerous. What's the normal exhaust temperature on these?
Well, like I say, normally it's around between 150 to 200 degrees. You know, obviously the flame's burning at about 700, so you lose a lot through the heat exchanger, and you would hope that it's dropped to around about 150 by the time it comes out of the heater itself. Well, certainly our heat exchanger temperature sensor will cut the heater off if the heat exchanger gets above 250 degrees. So you'd like to think that by the time the exhaust had got out, it was well below that. But that one I showed you was one of these Chinese clones, and there's quite a lot of those out there where the sensor isn't working. It doesn't stop them when they go over, and they just do generally run very, very much hotter than all the branded ones anyway out of the exhaust. Something to do with the burner design, and it's not transferring the heat as well as it should do into the heat exchanger.
Yeah. Also, for a survey, of course, it's really important to check this exhaust temperature to avoid any dangerous situations.
Absolutely, yeah.
Okay.
And as the CO issue is the real big one on them as well, more so than temperature. If there's any leaks on it, that is really critical.
Yeah. Okay. Thank you, Owen.
No problem.
Are there any more questions for Owen? Actually, I have a question, Owen. My colleague wanted to know, where is that picture of that boat?
I don't actually know.
It's one seriously iced up boat. It looks
Sure.
American, maybe, or
Yeah, I'm not quite sure actually. I'll find out for you. Let's put it that way.
it's a fabulous photo. Right, we've got a question from Jason, who asks, have you seen any osmosis issues around the exhaust outlets?
I can't say that I have. No, not seen any problems with that.
I hope that's a quick answer for you, Jason. Okay, says Jason, thank you.
Okay, brilliant.
Any more for any more? Yes, okay. He's seen a few in Canada, says Jason.
There you go. Yeah,
So
okay.
that is a possibility, yeah.
Right, yeah, yeah. Yeah, I suppose the other thing I didn't really go into on there was air ducting and how that can cause any issues as well.
Feel free. You've certainly got 5 minutes if you want to use the time.
Yeah, air ducting. Basically, our units they come in either a 60mm outlet or a 90mm outlet off the heater itself, and if you don't get enough flow through these heaters, it can cause them to overheat. Now, we had lots of problems at the beginning where they were fitting them, or the heater itself was very susceptible to overheat, and it would do a fault 0-1 due to the ducting being, if you had a 10-meter run on it, even at 90mm, we were getting issues of the heater overheating itself because it wasn't getting enough air over it. But what they've done now is they've altered it so that it will self-regulate the power of the heater, so that it restricts itself back down so it doesn't actually reach the heater cutoff point. Now, this can be really good as long as the ducting was well installed at the beginning and it's all correctly sized. So if you use 90mm all the way, it's not a problem. But if you've then got two vents on the end, say two 75s off a Y piece at the end, and one of them is a closer, you can end up trying to push the whole lot out of one 75mm vent, and it will get very, very hot. And what might happen is that you end up finding that the heater will only ever run at about 3/4 power because it ramps itself down to compensate for the fact that the ducting is restricted. So that's something to look at, is just, quite often the ducting is in the bottom of a locker, gets stuff dropped on it. So when you're checking over a system for somebody, just check that there is good free flow of air through it and that it doesn't show any signs of ramping itself down before it should do, which you can tell quite happily by listening to the frequency of the pump clicking. Usually in our heaters, they're about once a second. Most of the other ones are twice a second. So it's just a good pointer anyway to tell you that when it's running flat out, about once a second on the fuel pump means it's running at full power.
I've got another question actually, Owen, from Mike Chadwick. Is it a problem to have the exhaust outlet under canopy side openings?
I mean, you basically want to have enough flow so that it will get out. The fumes will escape easily without any restriction, and obviously not into the cockpit, I would say, for obvious reasons. Mostly the fumes will go upwards because they're hot, but into the cockpit would be a bad idea. But you'd have to review it on a case-by-case basis, really, as to whether the flow will go away easily.
And a question from Barney, who says, do you recommend annual service, or would you suggest another interval?
Well, our heaters, the factory don't actually recommend any servicing whatsoever. Running it once a month at full power is enough to keep them going. As I say, they should go 20,000 hours without any problem. And what will happen then is you probably start hearing the bearings go a bit noisy. So basically they say leave them running until they fail. And obviously if you hear any faults like the bearings going noisy, then you would get that looked at before. But unless there's a fault, it should just keep running. We've heard some of them run much longer than 20,000 hours without any issues at all, as long as they're run properly. Certainly the first heater I bought, which I bought directly from Russia probably about 6 years ago now, has been running almost every day in my own work van. And it's never missed a beat. It just runs. I turn it on. I've never serviced it. I've never touched it, not done anything at all. And it just runs perfectly every time we turn it on.
And Barney just continues. He says that's fine for the heater, but what about degradation in the installation and the exhausts and so on?
Well, again, it's just a case of inspecting it and having a look. That is the most important. Obviously, if somebody wants us to do that, we will come and look without any question whatsoever. But generally, people will notice that. They should hopefully have a CO alarm on board anyway. That was one thing that I would definitely say is critical. If they ever had a CO alarm go off, then you need to check it out. But these, when they're running correctly, the CO levels are very low anyway, and I don't think it would build up actually inside a boat. You would have to have something else wrong with it as well as an exhaust leak for it actually to reach fatal levels. Yes,
and as Barney points out, of course, boat owners won't look, and that is the sad reality.
It is true. It is true.
The whole thing about the carbon monoxide detector, they're not expensive pieces of kit, and I just don't understand why. It should be mandatory in my opinion, but best advice to surveyors, I think a surveyor should be recommending, if he goes on or she goes on to a boat that doesn't have one, it ought to go in the report just as a note to say you don't have a CO detector, you should have one.
Yeah.
It's a safety issue at the end of the day.
Yeah, we've added them now as a drop down on our shop whenever anybody's buying a heater, and they have to actively uncheck it to say they don't want one, because we feel that's the way to go now. It's not worth risk.
No, exactly. Okay, any more questions for Owen? I think you've done them over, Owen. Look, brilliant. Can I just thank you very much for joining? I know you came to this quite late in the whole process, so thank you for stepping in quite late in the day. It is not something we've really looked at as an institute, really, at all. And I'm sure I can encourage you to write something about this for a future edition of the Report magazine as well, just to push it out to a wider audience of surveyors. So thank you very much indeed, Owen, and I wish you a good day.